Hello all, welcome to the subject of microcontroller. I am Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvatibai Gyanma Moli College of Engineering, Wabuli, Pune. In the previous lecture, we have learned about how to interface the motor to 8051 microcontroller. So today we will see how to interface the relays to the microcontrollers. First of all, we have to see the introduction about the relay. So let's see how to relays are introduced here. The relays is an electrical switch that opens and closes under the control of another electrical circuit. In the original form, the switch is operated by an electromagnet to open or close one or many set of contacts also there. The relays consist of a coil of wire surrounding a soft and iron yoke which provides a low reluctance path for magnetic flux, a movable iron armature and a set of contacts. The armature is linked to the yoke and mechanically linked to the moving contact or contacts. It is held in the place by the spring so that when the relay is de-energized, there is an air gap in the magnetic circuit. So in this condition, the one of the two set of contacts in the relay is closed and the another set is open. When an electrical current is passed through the coil, the resulting magnetic field attracts the armature and consequent movement of the movable contact breaks a connection with the fixed contact and makes a connection with the other contacts. The figure here in the slide show about the symbol of the relay and interfacing of that relay with the 8051, simply making the pin 0 of port 1 which will switch on and off the relay. So this is the introduction about relay. Now let's see about the solid state relay. A solid state relay is a solid state electronic component that provides a similar function to an electromechanical relay but does not have any moving component and which increase the long-term reliability with the early solid state relays. And the trend of come from the fact that very translator has a small voltage drop across it and this voltage drop limited the amount of current a given solid state relay could handle as a transistor improved. The higher current the relay is able to handle the 100 to 1200 amperes and have to become commercially available. The compared to electromagnetic relays, they may be falsely triggered by the transition and the type of the relays are photocoupled state transition relay, transformed coupled state transition relay, and hybrid state transition relay. The photo-coupled state transition relay is controlled by a low voltage signal which is isolated optically from the load and the control signal in a photo-coupled solid state relay typically energized as a LED which activates a photosensitive diode where the diode turns on back-to-back thyristor silicon controlled rectifier or MOS transistor to switch the load. Here this figure shows the structure, internal structure of the solid state relay and it is interfaced to the 8051 microcontroller. So let's see few programs how to interface the buzzer to the 8051. Here we have to write the assembly language program. Assembly language program to interface the electronic device and that converts the electronic signal into buzzer noise. So we have to interface the buzzer here that is given to it. Here what will happen, we have connected or interfaced the electronic device to the 8051 microcontroller. So that electronic device is a with what it will do, which converts the electrical signal into buzzer noise. So simply here buzzer is connecting to the 8051 microcontroller and it is giving to it, and the buzzer can be used as an electronic bell or alarm. So we have to write program for that. Here we have considering the port 3.1 be an input bit. Here port 3.1 as a input bit and which represents the condition of microwave oven. So which represents the condition condition of microwave oven. And next is whenever it goes high, we have to the port 3.1 which indicates the microwave oven condition, but we have to monitor by using another bit by setting set or clear to monitor this port 3.1 pin. When that pin we are monitoring, that is by using this pin port 1.2. So port 1.2 we are going to monitoring this pin. It will turn on only when high to low pulse applied to this port. When high to low pulse applied to this, what will happen? The buzzer will be turned on. So this is the condition. We have to write the program accordingly. First we have to jump no bit on P3.1 comma L1. Here L1 is a loop. When there is no bit available at the port 3.1 is nothing but it does not perform any function. It will keep itself in a loop by repeating the same step execution. If the there is something bit or pulse entered into this port 3.1, then suddenly what it will do, it will set the bit of port 1.2. After suddenly it will set this pin. So now this pin is contains the value I. P 1.2 contains the value I. After that, we have to clear first by sending high to low pulse to it to make a buzzer on. So we have to clear because our buzzer will operate on high to low pulse. So high to low pulse is, first of all we have to set first, then we have to apply high to low pulse means 1 to 0. This transition should be operate there. So we are going to setting this bit clear 1.2. Now what will happen? The buzzer on high to low transition. This becomes 0, 1 to 0. Then buzzer on. Buzzer is in on condition. After that we have to perform the same repeating operation. Yes, jump by keeping the short jump to loop. This process will be continued. So this is a simple operation of interfacing the microcontroller to buzzer here. Now opto oscillator. An opto oscillator is a device that uses a short optical transmission path to transfer a signal between elements of a circuit, typically a transmitter and a receiver, while keeping them electrically isolated. Since the signal goes from an electrical signal to an optical signal back to an electrical signal, an electrical contact along the path is broken. The solid state relay has an opto-isolator at its input is shown here in this figure. The LED at the input trigger the transistor optically and hence no electrical path exists in between LED and the transistors. Here in the slide, the internal structure of opto-isolator and its interfacing with the 8051 is shown. So this is the opto-isolator. What it will do, it will isolate the electrical and optical signals which provide a short path, in between to transfer the electrical signal, and that converts into optical, and then it will transfer the optical signal to these transistors. So here the LED will be connected to the directly connected to the these transistors. So whatever the say optical signals available from this part it will access from this transistor, and it will convert again the electrical signal and supply to this LED. So this is the task of isolator. The design of data acquisition system. Here the computer are the tools that are used for the processing of information. However, before processing we need to collect the data upon which a computer can act. Its need to acquisition of the data or require the information from the source. The information should be converted into suitable form where further analysis and manipulate can be carried out. So, if you want to perform some task in a computer, we have to providing data to the computer. So based on that, it will perform the task. So before applying data, how we are going to apply data? We have to perform some task. So the data should be on that the computer should be at. So the processing on that data is called as a acquisition. So the acquisition of data or whatever the information we are providing from the source, so we have to give a proper data to the computer on that it will work. So the information should be converted in a suitable form where further analysis and manipulation can be carried out. So whatever information we are giving to the computer, so on that task should be performed by the computer. We have to provide in a very well manner so the computer can understand very easily. So and it will perform the operations on that. So the data is to acquired, it contained in a physical variable like a pressure, temperature, force and humidity. So the data that is to be acquired, which having the variables like a physical variables also there. So for example, pressure, temperature, force, humidity. So that data, that data first collect and then it is converted into digital form, and then it can be transmitted to displayed and sorted, whatever it is the form it may be. First we have to convert in a digital form. The data acquisition system is related to the process of acquiring the data in a digital form quickly, accurately, and economically. So this data acquisition system, what it will do, whatever the data, physical data providing inside it, it will quickly and it will quickly converted or produced in a digital form data very accurately. So the objective of the data acquisition systems are, first one is it must require essential data at correct speed and correct time. Second one is the data acquired must be efficiently used that they operate known the state of the system. In order to maintain the online optimum and safe operation of the the system must be continuously monitored. Then, the data acquisition system must be able to collect the summarized and stored data for the diagnosis of the operation and record purpose. An effective human system need to provide by the data acquisition system. It must be able to identify the problem areas, thereby minimizing the unit availability, and it maximize the unit output through a point at a minimum cost. And it must be able to compute the unit performance indices using online and real-time data. And it must be reliable and it must be flexible and capable for further enhancement. So next comes with a sensor and transducer. Sensors, they are used to convert the physical parameter into electrical signal, and the typical physical parameter include the pressure, temperature, humidity, flow, displacement, velocity, acceleration, etc. The transducer like a strain gauge, LVDT, load cell, RT, DS, thermocouples are used to convert the physical parameters into the equivalent electrical signal. And the electrical signal is applied to the electrical conditioning circuits. The signal conditioner, this block is used to produce the conditions so that the circuits works properly, and signal conditioning may include amplifying the weak signal to required level, modifying the data, and providing the excitation and balancing the circuits, and filter out the unwanted noise. For designing a signal conditioning circuit, the person must be more convergent with the op-amp design, and it is a critical stage to design because the input signal is weak and has a lots of noise in it. The digital to analog converter, it converts the analog voltage to digital equivalent, and it may contain a multiplexer that accepts the multiple inputs and sequentially connects them to converter. The digital analog to digital converter chips that are widely used in the industry are, that is 0808, 0809, and the ICL IC7108 ICL 710 bit. These are 12-bit resolution, conversion time is 33 milliseconds. Then another one is 8572, which is 12-bit resolution, conversion time is 35 microsecond. L-331 is used of the input frequency and is measured, and it is a calibrated in terms of the physical parameter, and the output of analog to digital converter is given to the microcontroller. Here, the output of analog to digital converter is given to microcontroller, and it will accepted by the microcontroller, and digital output and calibrated the same as per the required of the user. For the instant provides the keyboard and display. This is the main task of this data acquisition system. So this is enough for the day. We will continue the next lecture. Thank you.